Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in data science department in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about what are the various methods that are available for presenting data for data visualization. So in previous video, I discussed some of the topics that are related to presenting data, and this should be the continue of that. And then in this video, I'm going to explain what are the methods that are available. So very first one is that what is the data. So already I discussed in previous video. So let me show that what is the data again. So the set of values that are recorded on one or more observational units is nothing but a data. And then the object may be the data may be an object or person or anything. So anything in the real world should be considered as a data here. And then the data will be of four types. So very first one is that qualitative data, and then quantitative data, discrete data, continuous data, primary data, secondary data, and then nominal or ordinal data. So these are the various types of data. So already I discussed in previous video. So let me show that. So for presenting the data, so what are the principles we have to be followed? So very first principle is that the data should be arranged in such a way that it will arouse in interest in reader, right? So the data what we are going to arrange, so that should be in a very meaningful way, so that the reader can ably creates an interest for reading the data. So we should not able to create the data in an understandable way, right? So the data should be in a very meaningful way, so that it should able to create some interest for the reader. That is the very first principle for presenting the data. And then the data should be made sufficiently concise, so without losing important details. Suppose we're having some 100 lines of data, right? So for that 100 lines of data, what you have to do, you have to concise it to some 20 or 30 lines. So if you're going to concise means we should not lose that what the data is representing, that details should not be loosened, right? So that should be the second principle what we are going to be follow. And then the data should be presented in simple form, so that it should be enable the reader to form quick impressions and to draw some conclusions directly or indirectly. So right, so the data which is going to be presented, so that should be in a very simple form, and then that should be enable the reader, so in order to make the impressions quickly, and then can able to draw conclusions very easily directly, or it may be indirectly. And this should be the third way. And then the fourth principle is that it should able to facilitate further statistical analysis also. So what are the data we're going to present in the form of statistical analysis, that should be represented. And fifth principle is that it should define the problem and suggest its solution. So by once the data is collected and everything is done, so that the data what we are going to represent, it should be able to define some problem, and then the solution also going to be suggested. So these are the principles what we are going to be follow for representing the data, right? So let me see again. So the very first principle is that the data should be arranged in such a way that it should be announced interest for the reader. So what is the data I'm creating, that should be enable interest for the reader. And then the data should be made sufficiently concise. So what is the data we're going to compress it, so the compressed data should also able to represent the important details of that application without losing its clarity and all. And then the third principle is that the data should be presented in simple form to enable the reader to form quick impressions, right? And then the conclusion should be drawn, that may be either directly or it may be indirectly. And then the fourth principle is that it should be able to facilitate the statistical analysis. So once the data gathering and then collecting and then maximizing and then managing and all, and then we have to go for the analysis, that should be, we have to facilitate very clearly in order to make in the form of statistical analysis. And then it should also be define the problem, we are able to suggest the solution also. So the methods of presentation of the data we'll see now. So the first step is that statistical analysis is going to be present the data in an easy way to be understood. And there are two basic ways for data presentation. So very first one is that tabulation, and then charts, and then diagrams. So these are the some of the methods that we are having for presenting the data. So the first step is that the statistical analysis is to be presented in such a way that that should be easy and then easily understandable, right? And then there are two ways of data presentation. So first one should be tabulation, and second thing should be either it may be a charts or it may be a diagram. Then what are the rules and guidelines we are going to follow for tabulation, tabular presentation? We'll see now. So the first one is that the table must be numbered, right? So what is the table I'm preparing? That should be numbered, and then we have to briefly and then self-explanatory title should be given to the each table, right? So since we are going to maintain several tables, so for each table we are going to create some numbers, and then brief and some and self-explanatory title must be given to the each table, and the headings and columns and rows must be clear, sufficient, concise, and then fully defined. So the headings what we're going to create in the table, that may be either column or it may be a row, that should be very clear and then sufficient, concise, and then fully defined. Next one is that so the data must be presented according to the size of the importance, chronologically, alphabetically, or geographically. So these are the principle what we have to be followed for the table presentation. So the data must be presented according to the size of the importance, and then chronological way how to present it, and then alphabetical way, or you can able to present either through geographical way. So next one is that if the data includes rate of or proportion, mention the denominator, right? So if the data includes some rate or proportion, so we have to represent it in the form of denominator. And then the table should not be too large, right? So since they were going to take an application, right, so that we're going to maintain number of tables. So if we're going to maintain number of tables, and then if it is should be very large, then it should be even it is not that much easily to predict the tables and all. So the table should not be too large, and then the figures needed comparison should be placed as close as possible. So the figures what you are taking for comparison, so that should be placed as close as possible. So these are the some of the principles initially that we are going to create for the tabular presentation. So the first one is that the table must be numbered. So since an application is having so many number of tables, what we have to do, we have to give some numbering for the each table. Suppose that we are having some 100 tables we are having. Suppose one may be in a randomly are going to take, right? So instead for since we are taking the tables and all in the different ways, and then what we have to do, we have to first give what should be the first one, what should be the second one, what should be the fourth one, what should be the fifth one. So like this we have to give some numbers. Based on that, what we have to do, we have to give some explanatory title or brief title should also be given for the table. Let it be A, and let it be B, let it be C, or suppose if I am 4 to 4, number 4 is there, right? So let it be 4A and then 4B, like that. You have to be give some number as well as the title also. Once the title and then numbering is done, then you have to make it in ascending order: 1, 2, 3, 4, 5, and then 4A, 4B, and 5. Like this, we have to make this all the tables in a very ascending order very clearly, right? So then the headings and columns should also be very clear, and then sufficient, and then concise and fully defined. And then the data what we're going to present it, so that should be presented according to the size of the importance. So suppose since we are maintaining 5 tables, suppose the importance is goes to the third table, so we have to uh, arrange this should be first, so that the 3, 1, 2, 4, 5 should appear. Suppose if the table is having that much importance for that application, so then we have to do it according to the importance. We have to be do it, or I can able to present in the form of chronological way, or I can able to present in alphabetical way by considering the names of the table, or I can able to also present it according to the geographically also. If the data includes some rate or proportion, so what we have to do, we have to mention the denominator. Suppose if the data is having some 10.12 it is having, so then have to make it as 10 like this in order to represent in the form of removing the fractions, and also that you can able to represent in the form of uh, graphs very easily. Okay, then the table should not be too large. Suppose if the table is having some 100 lines of columns and 100 lines of rows, so what we have to do, we have to make it to reduce to some 50 lines or 20 lines, so that much this should be considered. So we should not maintain so many number of rows and so many number of columns, so that should be looks very clumsy, and then we can able to unable to predict the values and all. And then the figures what we are needing, right? So that one should be compared sometimes, right? So in order to do that, what we have to do, we have to be place all those figures should be as close as possible. So let's see the continuation of that one. And the classes what we are going to be defined should not lead to be any ambiguity. So the ambiguity should not be appear. So sometimes some tables may appear the same data. Suppose let me take a table row is having some data. Similarly, the table 101 is also having the same data. So that ambiguity should not be appear. So repetition should not be appear. Then the classes should be exhaustive. That means that it should include all the given values. Suppose if you are taking some 100 rows, means the 100 rows is having 100 values. We should not leave it somewhere. Value should be null, or you can able to put it as 0 like that. We should not be keep it like that. They definitely this should have some value. That type of variables only have to take it out, or that kind of rows only have to be shown. Other things are going to be eliminated. Then the classes should be mutually exclusive and then non-overlapping, right? So since we are going to tables in the form of classes, right? So that's why all the time the classes should be mutually exclusive, not should be in overlapping way. And the classes that we are going to be presenting should have equal width and or having equal class interval. Suppose if I am maintaining some class intervals like 0 to 9, and then 10 to 20, and then 21 to 30, and then 31 to 40. So equal class interval should be maintained. We should not take so 1 to 5, and then 5 to 10, 5 to 15, and then 15 to 20, then 20 to 100. So this type of things we should not be maintained while designing the tables, right? So equal class interval should be maintained. And the open-ended classes should be avoided as far as possible. So what are the classes that should be having open-ended mode, that should also be avoided. And then the number of classes should be neither too large or nor too small. So roughly it should be around only some 10 to 20 classes. That should be sufficient for single application. Suppose if the number of classes taking more than some 30 and 40, it should be also be very difficult in order to make the coding and all. And then suppose less than 10 should also considered as a very small also. That thing we should not be maintained. So here will be the formula for the number of classes here. So the class, how many number of classes should be there, and that one I want to find out, right? Now for that we're having an equation. So k is equal to 1 plus 3.3 322 log 10 log n base 10. So where n is the total frequency. So this is the equation we are going to maintain while defining the classes for a particular application and all, right? So these are the some of other principles of data presentation. So the very first one is that the classes should be defined and should not lead any ambiguity. And then ambiguity means repetition. So repetition should be avoided. And the classes should be exhaustive. Exhaustive means should all include all the given values. And then the classes should be mutually exclusive and non-overlapping also. So the classes what you are taking, so that should be mutually exclusive. So all the time non-overlapping should not be entertained here. The classes should be of equal width and then class interval should be same, right? So the classes what you are taking should have equal class interval or equal width will have to be maintained. And then open-ended classes should also be avoided as far as the possible. And then so next one is that the number of classes what we're going to define should be neither too large nor too small. That means the tables should be less than 10 is also not entertained, and then greater than 20 is also not going to be entertained. So the number of classes in between 10 to 20 is very good for a particular application. And then the formula for the number of classes will be k is equal to 1 plus 3.322 log n base 10, where n is the total frequency. Next, tabulation. So let's see the tabulation. So once we know the principles for the tabulation, so first we will see how the tables are going to be created by taking a simple application. So all the time the table should be simple or complex depending upon the number of measurements of single set or multiple set of items, right? The tabulations what we are creating, so that should be very simple, or it may be complex sometimes based on the application, depending upon the number of measurements of the single set or multiple set of items. So let me say the simple table how it will be. So title is that the number of cases of various diseases in Nair Hospital in 2009. So this is the title we are having. So the number of cases of various diseases in Nair Hospital in 2009 I want to create it. So this is the data I'm having. So for that I have to represent in the form of table. So what I have to do, I'm taking disease as one column and number of cases as the other column. So diseases means I'm taking like malaria, acute GE, and then leptospirosis and dengue, like that. So these are the some of the diseases that I found in Nair Hospital. So similarly, how many cases are there? So for malaria, it should be around some 1100 cases are available. For acute GE, it should be also around 248, and leptospirosis 60, and then dengue 100. So like this, I can having the data in the form of text, not in the table. So by seeing the text of lines, by studying all those lines, so how to represent it in the form of table, right? So that should be a simple table here. And then frequency distribution table with the qualitative data. So here the title is that the cases of malaria in adults and children in months of June and July 2010 in Nair Hospital I want to find out. So this, let me take the example of this one. So the cases of malaria, right? So one disease I'm taking. So the cases of malaria in adults, how many people are there, and then children, how many number of people are available only in the month of June and July in Nair Hospital I want to find out. So let's me take the type of malaria in June month and then July month, and under this June, so adult, how many number of people are there, in child how many number of people are there, simultaneously adult and child, and another column total. So Vivax is the case that I found, how many number of people are there in July, and that should be in adults how many 54, in children it is 9. Similarly, if I'm take in month of July, it should be 136, and child it is 23. So total 222. Similarly, falciparum, how many number of cases that are available here in June, and then child how many, and then in July how many number of cases are there in adult, and then July how many number, like this 1 or 4. Like this I can able to represent the data. The two variables I'm taking to consider here, that is adults and children here, but in the month of June and then in month of July. So similarly, I some defined some class intervals for diabetes. So let me take the fasting glucose levels in diabetes at the time of diagnosis I want to find out. So I want to create some frequency distribution table. So frequency, that is frequency means 110, 122, 129. That should be one frequency, and 132, 139 is one frequency, and 142, 149 is one frequency. 152, 159 is one frequency, and 162, 169 one frequency, like this. So this and all we can able to call it as frequency distribution table with the quantitative data. So I want to find out what should be the glucose level for in diabetes, and for male and then female. So male should be one column, female as another column. So in between the number of people in between 120 to 129 frequency, the number of people are there is 8. Similar number of females will be 4. So similarly, I can able to find what is the frequency of 120 to 169, how many number of males are available, and how many number of females are available. For that I want to find out. So for that, what you have to do, you have to note 9 it is here, and it is 6, totally 15. So like this I can able to construct frequency distribution table by considering quantitative data. So once the table is completed, table representation, then we have to move for chart and diagram. So how the charts, what are the various charts that are available, and various diagrams that are available for data presentation. So the first one is that the graphic presentations are going to use to illustrate and clarity information. So normally this chart and a diagram is to be very useful and easily you can able to represent the text in the form of diagram, right? The form of diagram you can able to represent it. So that should be very easy one by making use of these charts and diagrams, right? But we have to illustrate, and then clarity information is to be represented here. And then tables, what you are taking in presenting of scientific data, and then diagrams are complementary to summarize these tables in easy, attractive and simple way, right? Suppose if I am going to represent the scientific data, so what I have to do, I have to take tables. Similarly, if I want to represent the complementary data, right, then the diagram should be very easy. Instead of tables, it should be very easy, attractive and then simple way. So these are the advantages of chart and diagram. So the chart and diagram is going to be used for the graphical presentations of the data to illustrate and clarity information, and then tables are essential only if you are going to be present the scientific data, and then the diagrams are going to be used to summarize the tables in an easy way and then attractive way. Next, so the diagram, what are the precautions or conditions you have to be follow for preparing charts and then diagrams. So the diagram should be simple in nature, so we should not maintain the complexities while creating the table. So diagram, sorry, that should be simple and then easy to understand. So you can able to understand by seeing the diagram very easily, and then you have to say a lot of words, and then self-explanatory. These are the diagram should have, and should have a clear title indicating its content. So by seeing the title itself, what should be the content, that much easily you have to present the diagram. What is the, instead of going inside and all, so the content what you are going to representing, that should be clearly specified in the title itself. and fully labeled. Fully labeled also is the diagram should be maintained, and then the y-axis that should be vertical is going to be used for the frequency normally. So all the time, so in a graph we are having x-axis and y-axis, right? So all the time this y-axis usually represent the frequency. We should not able to prefer x-axis as the frequencies, right? So all the time it should be y-axis should be considered here. So the diagrams should be simple and then easy to understand, save a lot of words, and then self-explanatory should be maintained in the diagram, and then the diagram should be very clear, indicating its content, and then the diagram should be fully labeled, and then y-axis is usually preferred used for presenting the frequency. So some of the varied charts and diagrams what we are having for data presentation will be bar diagram. So here the bar diagram is the one where you can able to represent the data in the form of bars. Again, these bars will be of two or three types, right? So simple bar is the one diagram, simple bar diagram, and then composite bar diagram, right? So like that, some of the different types and multiple bar diagram. So these are the some of the different types of bar diagrams what we are having here. And then histogram. So what is histogram? So histogram is also one type of diagram, bar diagram, but where you have to but there is no space in between one bar to the another bar. So that one should be considered as a bar diagram, right? So if you are not going to need any kind of bar or any kind of space in between one bar to another bar, then that should be simple bar. Suppose if you are not maintaining any kind of space in between one bar to the another bar, so what will happen? That should become histogram. That is the only difference what you have in the bar diagram and then histogram. And then frequency polygon. So see, frequency polygon is also another type of diagram for representing the data here. Here the frequency polygon should be considered this middle part of this. Then after removing this, then that should become the frequency polygon. So in further slides, I'm going to show that how the frequency polygon will looks like that. And then cumulative frequency curve is also there, so that one also we'll see now and further slides. And then scatter diagram. So scatter diagram is also one thing where you can able to represent the form of dots in the diagram. And then line diagram. So line diagram is also a line graph where you can able to represent in the form of graph by using lines. That should be line diagram. And then pie diagram where you can able to split the number of segments into different parts. That should be the pie diagram here. Let's see one by one bar diagram. So bar diagram is widely used, easy to prepare to for comparing categories of two mutually discrete data. Suppose if I want to compare the two variable data, at the time I have to make use of this bar diagram. And then different categories also there, which is going to be indicated on one on x-axis and the frequency of the data in another axis. And then the length of the bar is going to be indicate the magnitude of the frequency of the character to be compared, right? And then the spacing between the various bars should be equal to half of width of the bar. So suppose if I'm taking the bar right, the space in between the one bar to the another bar should be equal to half of the space of the bar. So the spacing between various bars should be half of the width of the bar. How much, right? This one should be maintained. So one bar to the another bar. And then three different types of bar diagram. Just what I said here is simple and then multiple compound or component of proportional bar diagram. Right, so the bar diagram is the one which is going to be easy one. So in order to predict the difference or comparison between the two variables, and that should be exclusive discrete data, and different categories also going to be indicated on x-axis, and frequency of data are also going to be represented on another axis. So the length of the bar indicates the magnitude of the frequency of the character to be compared, and then the spacing between the various bars should also be entertained, which should be equal to the half of the width of the bar. And there are three types of bar diagrams available. So first one should be simple bar diagram, multiple or component bar diagram, and component or proportional bar diagram. So the widely used one, so that should be very first thing. And then all the time this bar diagram is going to be used for discrete one, and then what are the categories we are having, that one should be represented on one axis, and frequency is going to be represented on another axis, and where the length, right? So in bar diagram we are having different lengths. So then each length is going to represent the magnitude of the frequency of the character that is going to be compared, and then the spacing between the various bars should be half of the bar width of that we have to maintain. So this is a simple example. By seeing this, what we are going to identify is suppose what is the total number of cases that are available in males, particular disease what we are having. So vivax and falciparum and then mixed malaria. So how many number of cases are available, I want to find out in male. So by seeing this bar, what we are going to identify, so the vivax in male is around 100 people are available, and by seeing this graph, what we are going to say that is, so the falciparum disease in males should be around 60, and this should be around 100, and the mixed malaria number of cases in male, right, male cases will be around some 30. So like that I can able to predict the data very easily by seeing the diagram instead of studying the text and all. And then multiple bar chart. So here the multiple bar chart means where you can maintain the more than one bar for a particular variable. So the each observation has more than one value that should be represented by a group of bars, and then the percentage of males and females in different countries, and then the percentage of deaths from heart diseases in old and young age, and mode of delivery in different female age groups. I want to represent it. So this is the observation what that should be get from multiple source, and then the information is that, so each observation has more than one value, right? That should be represented by group of bars, and the percentage of males and females in different countries I'm going to find out, and then what should be the percentage of deaths from heart diseases in old as well as the young age, and mode of delivery in a different female age groups. Like this I want to find out. So for this, seeing that what you have to do, single bar diagram is not sufficient for representing this kind of data. So for that, what I have to do, I have to go for the multiple bar chart diagram. Look at this. So the number of vivax, so that is vivax in male and female I want to find out simultaneously. So for that, single bar is not sufficient here. So for that, what I am doing, so I have to make use of multiple bar diagram simultaneously. So the vivax in males, how many it is, and in females, how many it is, I want to write, right? So for that, what do we have? We have to make use of this multiple bar diagram or component bar diagram. So similarly, falciparum is a disease that should, the blue indicates that male, and then red indicates the female. How many number? It should be around 62 in male and 31 in male. Female are available. And similarly, in the mixed malaria, how many number of males are available and how many number of females are available? That will be 29 and 19. So like this, I can able to represent the multiple bar diagram. And the next one is component bar diagram is the next one. So the component bar diagram is that here the component bar chart is going to be represented by making use of subdivision of the single bar, which can also be represent or indicate the composition of total divided into sections according to their relative proportion. Let me show the diagram first. So this is the component or proportional bar diagram. So here what will happen, in a single bar itself where you can able to represent the different sections, and then each section is going to refer to particular portion of that one, right? So the subdivision of a single bar is going to be indicate the composition of the total divided into sections according to their relative proportion. Let's see the example now. Here two communities are going to be compared in the proportion of energy obtaining from various foodstuff. Each bar represents energy intake by one community, and then the height of the bar is 100. If it is divided horizontally into three components, so that should be protein is one component and fat is one component and carbohydrate is one component of the diet, and each component is going to be represented by different color or shape. So this is the example what we're having. So the two communities are available. So in order to make the proportion of energy what they're going to obtain from various foodstuff, and then each bar going to be representing energy intake by one community, and then that bar is going to be divided into three proportions. So first one should be the height of the bar. That one is going to be divided into three components. So first one should be protein. So how many protein is available, how much fat is available, and how many carbohydrates is available for the diet of a particular person, right? So in order to represent it, definitely I have to need the component or composite bar diagram. See the example here. So what is happening here? So the poor community people is going to maintain. So blue indicates only 10% of energy obtained from obtained carbohydrate, and by seeing that what I can able to get only some 10% of energy obtained from protein, and 80% is going to obtain fats, right? So like this, by seeing this component composite or component or proportional diagram, I can able to predict the data. So by taking pure comment, suppose in rich community what is going on, so 15% of people is going to get energy in the form of carbohydrate, and 30% is going to get protein, and 55% of people is getting fat here, right? So this is the comparison I want to take, the proportion of proteins in poor community and in rich community. So this is the one of the bar chart diagrams where you can able to represent it. So first one should be single bar diagram where how to represent the comparison should be done for a particular single variable, and the multiple bar diagram means we are going to maintain the two variables here. So the two variables are going to be compared simultaneously, then you have to go for a multiple or component diagram. And next one is the proportional or composite bar diagram where the bar diagram is going to be divided into different sections here, and each section of that variable is going to be represent some particular portion of that variable. And next one is that histogram. So histogram is the one so which is very similar to the bar chart, with the difference that the rectangles or bars are adherent. That means we should not maintain any gaps in between them. Then simultaneously that should be histogram here. So histogram means it is very similar to the bar chart, but there should be one difference here. So difference is that in between one bar to another bar, if we are not maintaining any gaps, that should be histogram. So it is used for presenting class frequency table for the continuous data, right? So for continuous data, all the time we have to make use of this histogram frequency table, and each bar is going to represent a class, and its heights represent the frequency, that is number of cases, and then its width represent the class interval. So each bar represent a class, and its height represent the frequency, its width representing the class interval, right? Suppose here this is the histogram we are having. So in this histogram, so each bar is going to represent a class, and its height is represent frequency number, and that width represent the class interval. So this is the various factors that are related to the histogram. So histogram means which is similar to the bar chart, with the differences between the rectangles and then bars should be adherent. That means without any gaps you have to maintain, and this one is going to be used to present the class frequency table. So this is very important. So for the continuous data, this should not be applicable for the non-continuous data. And each bar is going to represent a class, and its height represent the frequency or the number of cases, and its width represent the class interval. See the example. So in between uh, 0 to 100, this is one frequency, and 100 to 110 is frequency, 110 to 120 is the frequency, 120 to 130 is one frequency, 130 to 140, and then 140 to 150 is one frequency. These will be the frequencies. Now by seeing this, what can able to understand? So 0 to 100 number of people are available in 10 here. That should be the height. And then 100 to 110, and how many number of people are available? That is 14. So like this, I can able to predict the data by seeing the histogram also. So histogram means where we should not maintain any gaps between one bar to another bar. That should be histogram. Suppose if I am maintaining some gaps in between the bar diagram, then it should be a normal diagram, normal bar diagram. And next one is that frequency polygon. So what is the frequency polygon? So frequency polygon is going to be derived from histogram only by connecting the midpoints of the tops of the rectangles in the histograms, right? So the frequency polygon able to derive from the histogram and by connecting the midpoints of the tops of the rectangles in the histogram. That should be the frequency polygon. So let me take this. So this is the histogram what we are having, right? So histogram also similar to the frequency polygon. Suppose the line what is joining connecting the midpoints of the bar diagram, right? So that one should be considered as the frequency polygon. The line connecting the centers of the histogram rectangles are called frequency polygon. The line which is connecting the centers of the histogram rectangles, that one is going to be called as frequency polygon. We can draw the polygon without rectangles, so we will get a simpler form of the line graphs, right? We can also draw the polygon without rectangles, then it should be a simpler form of the line graph. Suppose if I'm going to eliminate these bars, right, only lines are available, then it should be the simpler form of the line graph by eliminating the rectangles. And then the special type of frequency polygon is the normal distribution curve. So normal distribution curve is one of the case of the frequency polygon, or which may be a special type of the frequency polygon. Right, so the frequency polygon means it should be able to derive from the histogram by connecting the midpoints of the tops of the rectangles in the histogram will be considered as the frequency polygon. So the lines which is connecting the centers of the histogram rectangles, that one you can able to call it as frequency polygon. And then we can also draw the polygon without rectangles, then automatically it should be the simple form of the line graph. And then the special type of frequency polygon is the normal distribution curve. See, this is the example of the frequency polygon. So the fasting blood glucose level in diabetes at the time of diagnosis. So this is the frequency range I am taking. So 110 to 120, 130 to 140, 139, 140 to 149, and 151. Like that, this I am taking the frequencies range here. So in between them, I am connecting. Actually, the bars is available here. Like this, the bars are available actually. So if I'm going to connect the midpoints of that graph, right, of the bars, then automatically it should become the frequency polygon. So this is the frequency polygon. Actually, we are having bars, right? So if I'm going to connect the midpoints of the center of the bars, right? So at that time, it should become a frequency polygon. Like this, I have to draw it. then it should become the frequency polygon. Right, the frequency polygon like this you can able to draw it. And then cumulative frequency diagram. So cumulative frequency diagram means, so here the frequency of the data in each category represents the sum of the data from the category and the preceding categories. Suppose if I want to hear the frequency of the data is going to be of one category, I want to represent it. At that time, what I have to do, I have to represent the sum of the data from the category as well as the preceding categories have to be taken. And then the cumulative frequencies are to be plotted opposite the group limits of the variable. So here the cumulative frequencies are going to be plotted, which should be opposite to that of group limits of the variable. And these points are going to be joined by smooth freehand curve to get the cumulative frequency diagram or OGU. So this is the underway, or you can able to call it as OGU. OGU is the under name of frequency, cumulative frequency diagram. Right, so the frequency of the data in each category is able to represent the sum from the category and the preceding categories. And then the cumulative frequencies that are plotted are opposite to that of group limits of the variable. And then these points are going to be joined by smooth hand free curve in order to get the cumulative frequency diagram or OGU like this. So this is the simple example of the OGU. And then suppose this is the bars initially we're having. So by taking this graph, so what we have to do, we have to construct the bars here first. Okay, so once the bars is given, so what I have to do, I have to connect the midpoint of the each bar. Right, so once we connected that, then I have to make the shading and all. Right, so once the shading is done, then that the diagram what we are getting here is should be OGU, that is cumulative frequency polygon. So like this I have to construct the OGU here. And the next one is that scatter diagram or dot diagram. So it can also be called as correlation diagram. So correlation diagram is that it should be also very useful to represent the relation between two numeric measurements here, and then each observation being represented by point corresponding to its value on the axis. So the scatter diagram or dot diagram can also be called as correlation diagram. So it is useful to present the relation between the two numeric measurements, or each observation being represented by point corresponding to its value on each axis. Right, so in negative correlation, the points will be scattered in downward direction, meaning that the relation between the two study measurements is contraventional. That is, if one measures increases to the other decreases. Right, so while positive correlation, the points will be scattered in upward direction. So a scatter diagram or dot diagram, so how that looks like. This is the view of the scatter diagram where you can able to represent it, or dot diagram. Right, so it is useful mainly to represent the relation between the two numeric measurements here. So suppose two numeric measurements I want to represent it, so what I have to do, I have to make use of this correlation diagram, and each observation being represented by a point corresponding to the value on the each axis. So here we're having two types of correlation. So first one is that negative correlation, and another one is that positive correlation. So in negative correlation, what we are going to see that the points will be scattered in downward direction here, whereas in negative positive correlation, the points will be scattered in upward direction. So negative correlation means it comes in downward, and positive correlation means it comes under upward direction, meaning that the relation between the two studies is contraventional. If one measure increases, another is going to be decreases. That should be the scatter diagram or dot diagram. So this is the simple view. Suppose May 30, I want to represent it, and then how many number of malaria cases in June 2009, like this. This should be the value corresponding to the July, and then August. It should be around 400 cases are there in August 2050, and 304 cases are available in July 2000. and then 89 number of pairs are available here in June, and then May. So this and all will be considered as dots. You can able to call it as dot diagram or scattered diagram. And the next one is that line diagram. So line diagram is a diagram which is going to show the relation between the two numeric variables, but the points here are going to be joined together to form the lines. So either it may be a broken line or it may be a smooth curve. So it should also be used to show the trend of events with the passage of time. It should be line diagram. So this is also a line diagram showing the relations between two variables. Suppose I want to show the relation between the two variables, right? So one line is going like this, another is going like this. So normally you're going to see this line diagram in sports here. So how many number of scores that is scored by India, and then how many number of scores that is scored by the Pakistan, like that. I want to view that. So I have to make use of this line diagram. So this line diagram is able to show the relation between the two variables, and then here the points are going to be joined together to form the line. So the line should be either a smooth curve or it may be a broken line. So which can able to show the trend of events with the passage of the time here. And then last one is that pie diagram. So pie diagram is one, so which can able to represent the data in the form of a circle here. So here the circle is going to be partitioned into various segments. Normally all the time we're going to consider 100% of the segment. 100% that one is going to be represented in the form of segments here. Each segment should represent the proportional composition of the total frequency, right? So each segment represents the proportional composition of the total frequency. So the pie diagram is the one. Here we're going to maintain a circle. So this circle is going to be divided into some different parts, right? So let be 10, 20, 25,000, 30, 40, 50, 70. But overall this thing should be 100 only. So the circle which is going to be divided into various segments, which should be also equal to the frequency, let it be 100%, and each segment represents the proportional composition of the total frequency, right? So this is the pie diagram for a particular application what we seen previously. So how many number percentage of people are having suffering from mixed malaria. Similarly, how many percent of people are suffering from vax. How many number of people are suffering from falciparum. I want to know. So at the time, how to, by seeing this diagram, it's very clearly you can able to identify that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.